Hi everybody and welcome back to Capricorn Radio. This is your host James and I'm delighted to have a returning guest today. We're going to be talking to Dr. Brooks Agnew, previous guest on the show. Had such a fascinating discussion last time. Really looking forward to getting a few updates with Dr. Brooks Agnew today. A little bit about Brooks before I bring him on. Raised in Pasadena, California, Dr. Brooks Agnew spent most of his youth hanging around Caltech and the folks who co-opt at the Jet Propulsion Labs. Entered the Air Force in '73, where he became electronics engineer. And after earning an honorable discharge, he attended Brigham Young, Western Kentucky, and Tennessee Technology Universities. He's a bachelor's degree in chemistry, a master's degree in statistics, and a PhD in physics. He was featured scientist in the '97 Wendy Robbins documentary on HARP, Holes in Heaven, and if you haven't checked that out, you got to get a copy. He's currently the president and CEO of Vision Motor Cars, Incorporated, designing and manufacturing affordable electric vehicles for highway use. Without further ado, let's bring on our super exciting guest. Hi, Brooks. Welcome to the show.
Oh, it is good to be back on Capricorn Radio. Thanks.
Brooks, great to have you back. You know, the funny thing is, I think we talked about this last time, Brooks, but I was in Stranraer yesterday. I came home through your native town on the boat yesterday back to Belfast.
Really?
Yeah, because I don't normally get the boat. I went over for a TV interview in Glasgow, and I've been navigating around Scotland, and it's been such a long time since I went back to Scotland. I used to live in Lockerbie in South Scotland, but I was thinking about it because I was like, how strange I have Brooks Agnew on the show tomorrow, and I'm coming through his hometown of Stranraer.
Oh, so. I know. That's great. Yeah, Stranraer. No one really associates it with us, but you're looking Agnew Bay right next to Agnew Park.
Yeah, and then it's such a beautiful part of the world. I love South Scotland. Most people don't get to visit it unless you're going to either Northern Ireland on the ferry or we look across towards the southwest Scotland. You see across from Antrim, but beautiful part of the world. And it's such a long time since I did that route, Brooks. I was thinking of you yesterday in your hometown. But yeah, such rich history around there. The castles around there are gorgeous, and it's just beautiful territory. Absolutely beautiful.
Yeah, it really is. I've been there once. I stayed a few days there, and it was really good to meet all the people and, to see the heritage of Agnew everywhere, all the cemeteries and the castles and the legends and the artwork.
And the fine really Scotch whiskey as well, Brooks.
That's right.
For sure. Brooks, the last time we had you on the show, we were talking about a multitude of things. I guess I'll probably go back to hollow earth for a bit and talk about some of the physics of that as well. And, you are the serious physicist. I want to point that out before we get into anything what we're going to talk about. Yes, we're going to talk some alternative stuff, but you are a serious physicist. You've got multitudes of papers out there. But tell us a little bit about that part of your life. You're also into electronic engineering, so you're a hands-on physicist. You seem to be in both worlds, and I find, just this is for the listeners more than anything, Brooks, I find you either find two types of people in this world in the science. You got the physicists or you got the engineers, and there never seems to be a migration from one to the other.
I know that's a sad thing. The physicists are always hiring engineers, and vice versa. So, I started out as an engineer, and when I worked in the field for about 10 years. I was going to go back and get an advanced degree, and I went to my supervisor and I said, I want to go back and get an MBA. He said, don't waste time. I mean, an MBA, I have an MBA. It hasn't helped me at all. He said, if you want to do something, go get a degree in statistics, like quality. I said, what? So I started the master's course, and the first year I was bored out of my brain because of all the math, but then I started to see how the mathematics helped me analyze manufacturing. Then I started to see, how to improve processes, how to fight root cause analysis, how to do variation prevention, and the whole world of manufacturing opened up to me. Well, just because I knew what was wrong with the world, I wanted to know what were the solutions, how do I design things to make it better. And that's where the physics came in. And I already had a physics thesis done from my undergraduate work when I was in the oil business as in the exploration side. And I had a ton of field data. So my proctor just encouraged me to write it up and take the classes to back it up. I did that. It was terrifically hard because most of the classes I took were extension courses, which means you're not sitting in a classroom. You're slugging your way through the textbook on your own and then talking to a professor a couple times a week. And frankly, about 75% of the students drop out because they just don't have the determination to go through it. They'd rather sit in a classroom for 3 or 4 years and get the degree that way. But there are a few that make their way all the way through, and I got the degree. And man, it was satisfying in the sense that now I really had the skill set to be able to, write a thesis like that. But it was also a detriment in that it made me practically unemployable.
Yeah, I come from an engineering background myself, Brooks, and mechanical engineering, and I did a physics astronomy degree. I couldn't do any more than that. To be honest with you, it was just too much for me. The statistics that is in quantum physics, it's just crazy. I mean, the math I struggled a bit with, and I'm good at math, but I mean, it's heavy math. I mean, so I commend you on the statistics and the math.
Well, people get, excuse me. People get lost in probability theory, and it's easy to do permutations and combinations, but the integrations and differential equations, that's where, it separates the men from the boys, I guess. I found that it helped me, get to solutions a lot quicker. And I was really kind of frustrated that my calculus teacher didn't show me that years before, because it would have made a lot of things a lot easier. But you really have to have that mindset. I think I often say it takes a really twisted mind to be good at this. And
I agree.
Most of the theoretical physicists that I know are not terrifically good mathematicians, and vice versa.
Yeah. You know what? I remember it was partial differentiation I had. I just thought it was mind-bending. But when I got it to work and I seen it, it was beautiful. It is beautiful. It's beauty. There is beauty in mathematics. I will put my hand on my heart and say that. But it's mind-bending to get there sometimes.
Yeah, it really is.
Wow. So, Brooks, I mean, we talked about Hollow Earth last time. We're going to probably get into that again. What is it about the public consciousness that is just absorbing this stuff, Brooks? I mean, people are philosophizing about this. They want to know, not just a fanciful idea of Hollow Earth. They want to get into some of the physics. And I find the public consciousness, it's absorbing more physical concepts these days. They're more into science. They're more into history. The layman's knowledge is really high these days, Brooks. But the public consciousness is just absorbing this whole hollow earth theory, like it's the last day on Earth.
And it's probably one of the more remarkable things about this style of planetary core geology that just blows my mind. I got involved in the project in 2005 when I was trying to find out some more information about at least how ancient civilizations viewed the advent of that maybe the earth might be hollow. There were all kinds of legends. I found them in Egypt. I found them in Scotland. I found them in Tibet, China. And there were traditions, even in the Christian records, even in the Bible, it talked about, the lost 10 tribes coming forth out of a highway of ice out of the center of the earth. And so I found it fascinating, but I also found it impossible because, I was, learned like everybody else that we live, everyone knows, on a molten ball. We float through space. We happen to live on tectonic plates that float around on a molten ball like cornflakes in a bowl of milk. And that's the way planets are made. But, the more evidence that I gathered, and I have to confess, it was multidisciplinary. There was data that came from the USGS. There was data that came from satellite imagery. There was data that came from magnetometry. And the interesting thing is that none of these sciences were talking to each other. I seem to be the only guy that was pulling these pieces together and saying, you know what, this really makes an interesting puzzle, and it doesn't look anything like what the geologists are telling us the planet is made, out of. And then when the Japanese came up with the data that confirmed that the core of the Earth is actually a solid iron crystal, now they theorized that it was at 5,000 degrees C, which is quite a bit cooler than the sun. And that threw everything off again. And I thought, well, maybe they're right. And then a year later, two universities, Cambridge and I believe it was Washington University, did a joint experiment. They duplicated the Japanese experiment, except they used what's called a diamond anvil. They actually created almost a microscopic version of the iron crystal in the center of the Earth. And they very accurately measured 6,000 degrees C, which is the temperature of the sun. That made sense. That tied everything together again. So it was live again. And now we have, just this last week, Harvard issued another very detailed paper about how they have discovered ancient continents underneath the crust of the Earth. And it was just a few years before Washington University under Dr. Weiss Sessions published an analysis of 600,000 seismograms where they determined there's another ocean underneath the Atlantic Ocean. Now, this is all very compelling evidence that we don't live on a molten ball floating around in space. We live on something much more complex and dynamic. And what it does, it doesn't necessarily prove that the Earth is hollow, but it disproves the current theory.
So people are going to want to build up a picture, Brooks. What are we saying? We're saying there's like a crystal in the center. There's probably gaps then of fluid, liquid, air, and then another layer, and then maybe gaps again, or caverns, or it's not necessarily just a nice big spherical hole or spherical hollow in the middle.
Well, let me bring in what the plate tectonic professors theorize from Stanford University. And they're probably one of the more progressive universities in the country as far as actually having gone out and taken samples and putting probes on tectonic plates and watching their movements. They seem to back up the idea that Earth was once much smaller in diameter than it is right now, that the continental shelves, not necessarily the dry land that we see above the oceans, but the continental shelves of the continents were once all linked together, all sides. And that means that the Earth was, probably less than half its current diameter.
Wow.
And that makes a lot of sense, because if you look at the geological age of mountain ranges like the Himalayas, the Rocky Mountains, the Appalachians, the mountain ranges in South America, you find that they are about 4.5 billion years old, which makes sense. That's about how old the Earth is. But cores taken in the ocean floors find them barely 10 to 15 million years old. So when you have such an age disparity, it means that the ocean floor is a recent addition to the planet. It means that the crust has been expanding, and as it did, these giant cracks formed in the Earth, the water receded from the mountains and fell into the low areas like the trenches and huge valleys between the continents. And that's why we see layers of sedimentary seashells 10 and 12,000 feet up in the mountains. And we see still today the crust cracking open on the ocean floor and filling in with magma.
Wow. So the whole idea of plate tectonics is really in trouble. It's not. What do we say? It's a fallacy? Do we say it's problematic? Or
well, I wouldn't say the whole theory, but the theory that there is subduction going on. That is to say, one tectonic plate shoves under another one. That theory is completely flawed. What is actually happening is portions of the plate are at pressure zones like the Pacific Rim and areas in the subatlantic. And we see that those tectonic plates are moving against each other, but they're not floating underneath one another. They're separating from one another. The crust, although it's very slow now, is still separating. It's still expanding and cracking and cooling and changing the diameter of the Earth.
Wow. Yeah, I talked to somebody recently, and they say there's like cavities, or maybe there's caverns. This could be maybe a confusing for maybe mythologies come from, Brooks, that there may be deep cavities near the surface. It doesn't necessarily link in with the hollow earth theory, or does it?
I don't think that it does. The crust, if the seismograms are correct, and we're reading these shear waves and pressure waves correctly, and I'm not saying that the way that they do it is terrifically accurate, It may be precise, but it's not accurate. There's a difference. It's sort of like good grouping with a bow and arrow, but you're not anywhere close to the bullseye. Good accuracy, or good precision, not good accuracy. And so what we see is that the crust is probably about 800 or 900 miles thick. Now, any cavity that we could see with any technology that we have, even HAARP can't see this deep. The frequencies just don't go that far through the earth. Maybe 8 to 10 miles is about all we can see. So we're just seeing, barely into the top few, layers of the upper crust. We're not seeing deep into the earth. The only way to see that is when we do kind of a CAT scan of the earth, when there's a really hard earthquake on one side of the earth and the geophones on the other side of the earth pick up those vibrations as they go through the crust. Then we can kind of get a picture of it, but we don't have near enough geophones around the planet to get a clear picture. They're way too far spaced apart. What we do see, though, is that there are anomalies somewhere around 800 or 900 miles deep. And that means that there's an interface between the crust of the earth and some space in between that and whatever makes up the core. Now, when you couple that with the fact that we've got a double layer magnetosphere around our planet, which is clearly the result of a generator, like a motor,
Sure.
Where we have an iron core of the earth with its polarity, and it is rotating at one speed, and then we have an iron nickel crust that's rotating around it at another speed. Well, that differential between the crust and the core is what's generating that magnetic field.
Wow, how wonderful. So the magnetic field may actually be the result of this hollow earth, Brooks, is what we're saying.
I think it is, because we look at a lot of planets, and now we're able to measure the magnetosphere around these planets. One of the most remarkable things is we're noticing some planets, like Mars, have no magnetosphere at all. It doesn't mean that they're not, volcanically active underneath the crust. They probably are, but they just don't have a solid core against which the crust is counter.
So do we have any other examples of hollow planets?
Yes, we do. Pluto, as you know, it was once our 9th planet.
Yep.
Then just a few years ago, they said, oh, sorry, mistaken. Pluto's not a planet anymore because, well, we're sorry to report it's hollow.
Take the solid crystal of the Earth. Does that show up in any other way other than magnetics? Does people say that used to be, or maybe I think it was a Russian researcher. They said that may be actually a giant crystal, and it's got nodal points on it, like how complex the geometry is. It's like a geometric crystal, and that would show up as nodal points on the planetary measures.
It
an
could
earth,
be.
like an earth grid.
What the Japanese were able to return was what's called a spectrographic signature. Now, whenever we do a spectrometry, we usually excite the sample with some other kind of energy. We either bombard it with electrons, or we hit it with infrared radiation, or we stick neutrons to it and wait for them to decay. So we measure spectrometry in extremely precise ways. We're looking for specific wavelengths that are characteristic of certain molecular bonds or certain atomic weights. And what they have found from the core is that the frequency is extremely pure. That is to say, it's a single spike on the spectrograph, and it's right on iron. It's right on the iron molecule. So it isn't a compound with something else. It's a pure iron crystal, and it right now they're measuring it at 6,000 degrees C, which makes a lot of sense.
Wow, this is mind-bending stuff. We're right in saying that the gravity is not in the dead center of the Earth as well. Is that correct?
Well, it is in the dead center of the Earth, but when you look at the distance between the sun and the Earth, there should be a point of equidistance. That is to say, you're not being pulled to or repelled from the Earth or the sun. It's called the Lagrange point. It's a point where you can put a satellite and it will stay put. It's not going to go anywhere because it's not being pulled to either one of the planets. We can measure these points between planets and the sun very, very precisely. The Earth's Lagrange is 1,200 kilometers off. it lacks 1,200 kilometers of reaching the exact center of the Earth relative to the sun. That tells us that Earth is actually made up of two masses, not one.
Wow. Wow. Does that even say anything, the relative size of the masses to each other, or with that 1,200, can you do anything with that number?
Well, I think the resolution isn't there,
right,
but it seems to point to the fact that the diameter of the Earth and the known density of the Earth don't make sense.
Doesn't tally up.
The core is probably upwards of 11 to 14 grams per cubic centimeter, and the surface, even solid granite, is probably 6 to 8 grams per cubic centimeter.
Wow. Of course, Byrd, because a lot of people, if they're going to talk Hollow Earth, they're going to mention this. Now, I'm talking to a scientist today, Brooks, and I'm talking to an engineer, and this is what we're talking about, this in a very scientific, technical function. But there's obviously Admiral Byrd's diary, this whole fallacy about the whole diary thing, but there is evidence that he was, though, there, Brooks, and he did make some strange comments. That this part is true, yes?
He made some strange comments when he got back. He said that he flew from the subarctic aboard a 3-motor Ford aircraft, which he and his 2 engineers had stuffed full of extra fuel. And they flew at about 2,500 feet altitude, which it's suicide. I mean, to fly at that altitude, of course, they're flying pretty slow, about 140, 150 miles an hour. They flew for a long time, something like 12 hours up, and so they flew over what is known to be the North Pole, but what he reported is that he flew over expanses of green grass and liquid water, and there should not have been any there. It should have been just ice and maybe open ocean and whales. That's about all. But he says he flew over green grass. Now, that's all we really know. He did that in 1926, and then in 1929, he flew over the South Pole. There has been so much license taken with just those few statements, and I've watched all of his televised recordings, and I've listened to all of his voice recordings. He never went into any more detail than that. There was a reported diary out there. I read it. I compared it to the language style that he had in his previous writings, which were few, and his speaking style. And my determination, and I'm not a philologist, but I would say that the diary was a fake.
Sure. However, he did have really powerful connections, this guy. I mean, this guy was like a superhero and a patriot. He was like he was a legend.
Well, he wasn't a superhero, but he was a super patriot. If they told him to keep something secret, he would have. He was an admiral, and he was an amazing pilot, and that's why, he's not an aviation statistic like I would have been. He gained his rank because he was battle hardened, and I've watched interviewers ask him tough questions, and he's very skillful. I doubt very seriously that he went off into the esoteric to any depths at all. He wasn't that style of person.
Wow. Did you go in kicking and screaming to this Hollow Earth theory? Did you come in, I'm not going to buy any of this, I want to get, like the scientists, get down to brass tacks and prove this all wrong?
Well, I've always maintained that the best way to approach the idea of Hollow Earth theory is to approach it with a null hypothesis. And that is to say, we're going to gather all the evidence that we can to prove that the Earth is formed exactly the way the current planetary core geology is published. And we could not prove that. Based on the evidence that we gathered, there was enough doubt in that theory that the hypothesis that planets form as hollow spheres is still viable. We just have not done enough experiments to be able to disprove it. But I would say that the theory that we live on a molten ball is also disproved.
Sure. You only look back and see how many times scientists have been proved wrong with something wacky happening. But the world is more complex and more interesting than we can even conceive, Brooks.
It is, and then there's almost a religiosity between the different disciplines of science. Geologists do not agree with archaeologists. Astrophysicists don't agree with geologists, and they don't talk. I mean, they don't even go to lunch together. Yeah. You don't see somebody from astrophysics publish in a geology magazine or go for a peer review paper. It just doesn't happen. That's probably the strangest thing that I found in trying to do this cross-disciplinary study, is that one expert will not refute another expert. For instance, one of my good colleagues, Michael Cremo, says that, a skeleton in an undisturbed layer of clay. Now, the geologist will say that clay is at least 4 million years old. But the archaeologist, the anthropologist, will say that's impossible because everyone knows man hasn't been on the earth any longer than 20,000 years. So this skeleton is no more than maybe 19 or 20,000 years old. You see, the two sciences are so far apart, but they will not, officially debate the question.
Wow, Michael Cremo's a good friend of the show. He's such an interesting guy, such a prolific researcher too, Brooks. What an incredible guy, he definitely is.
Yeah, I've known him for years, and he's a really gifted writer, a really gifted researcher. I think there probably isn't another credentialed archaeologist than he in our world.
I wouldn't like to go against him on a debate anyway, Brooks.
It's hard to go head to head with somebody who has physical evidence.
For sure. Yeah, and here's the thing. What you're alluding to there is, I think we need to bring back the day of the polymath, the day of the polyhistory, that, we need to get these diverse backgrounds. I think that we're trying to train people to be savants and, with these PhDs, and that's fine. I mean, we need that to do the research, but the problem that's got a downside too, Brooks. I think we need this polymath culture back again.
Well, I agree with you, but I think it's more of a scientific ethics than anything else. When scientists are gathering information or data from their experiments or their measurements, almost across the board, they have a tendency to throw out data that does not agree with their idea or for some reason pertinent. They just throw it out. And I have strove my entire life to not do that. If I find evidence that I don't know what it is, I don't throw it out. I put it in my lab notebook. Maybe next year or 10 years from now, that data is going to make sense to me. But I put it in there.
For sure. Let's come back to planetary science. Let's talk about the day the Earth stood still, because in ancient legends we talk about this day where the sun didn't shine for 3 days and the Earth stood still. How is this actually possible, Brooks, in physical sense? Because I don't get this. Is there an actual reasoning for this, that this could have happened?
Yeah, there would be. I mean, the moon, for all intents and purposes, is standing still. It's not revolving relative to the Earth. The same side of the moon faces the Earth all the time. It occurs when a body with a very much larger magnetic field or gravitational field comes into the proximity of another body. Not where the Roche limit is reached. That is to say, the internal gravity of that body is left intact. If it gets too close, it gets within one diameter of the smaller body, the larger gravity will tend to overcome the gravity of the smaller body, and it'll just rip it apart. So if a large rogue planet would have passed close to Earth, it would have caused the crust of the Earth to stop rotating. And 3 days is nothing. It could have stopped rotating for 6 months if it took that long for a planet to go by. But if the planet was moving pretty quickly, and we're moving at the rate of 18.5 miles per second around our sun, and then our solar system is probably moving at the rate of about probably close to 8 billion miles a year through space. So incredible. It wouldn't take long for us to pass a rogue planet if it was, passing through as a leftover from a collision with another galaxy, or just passing through space. So it is entirely possible, but statistically speaking, it is not very probable at all. But it could happen.
What's the chances of a rogue planet coming in, or a rogue star even? I mean, is our neighborhood not settled down, Brooks, or could this have happened relatively?
Well, I mean, in Kepler, which is a really good space program, says that probably 30% or a little more than that of all the planets in our galaxy are rogue planets. They're not revolving around a sun. They're just rocks, big rocks floating through space.
Wow.
They don't reflect light very well, so we're not going to get a lot of warning if something like that heads our way. It has to get close enough to us that the light from our sun lights it up. And that means, if it's the size of Mars, it's going to have to get within 55 million miles of us before we'll even see it.
Wow. Let's talk Nibiru, Dark Star, Nemesis, Planet X, whatever you want to call this thing. Could this have been the reason for this? Could this have been a permanent visitor to our part of the solar system?
Well, I go back to the writings of Immanuel Velikovsky. He wrote a book, Worlds in Collision, for which he was professionally excoriated in his day. Mm-hmm. But he in the book, he tends to take the writings in the book of Revelation and looks at it from an astrophysicist's point of view. What would a collision of Marduk with Tiamat look like? What would it have left evidence behind in our solar system? And what he decided in his book, and I think properly so, is that not only was it possible, but it was so well described in the book of Revelation that it probably already happened, because the evidence of it is in our solar system right now. So that's where the idea of Marduk, of Tiamat, of this whole idea of an errant planet coming through and disturbing our solar system in a major way. That's mm-hmm. where it came from. And the evidence is still in orbit around our sun.
Mm-hmm. Wow. What is that evidence? Bits of Venus and...
Well, for one thing, we have a missing planet in what would normally be a Fibonacci layout of orbits around our sun.
Sure.
Where that planet should be is the asteroid belt. So probably there was at least one planet in that orbit path, and whatever it was that came through here, some of the trash that it was hauling collided with that planet, and the combination of those two collisions is still in orbit in that ring around the sun. Wow. The other thing that we notice is on the surface of Mars, we see the fracture lines in the crust that are typical when a large body throws sudden and catastrophic, what we call tidal gravity, against a smaller body. The crust begins to stretch and squeeze, and the crust will shatter. Mm-hmm, mm-hmm. And it looks sort of like a soccer ball when the tectonic plates that are on it are literally broken apart like a skull and healed back together. The other thing that we notice is that its entire atmosphere has been stripped away, not leaked out into space naturally, mm-hmm. but stripped away by a close passing gravitational body, which certainly would have happened.
Wow. I did a physics with astronomy degree, Brooks, and in Mallorca, and I loved it out there. I was up I did Open University, in part-time and summer schools and stuff, but, planetary science was one of the modules I had to do, and I asked that very question about the asteroid belt, and could it have been a planet that was smashed? And the planetary scientist, I didn't like planetary science anyway. It was just a module I had to do, but I thought I'd ask the question to the right guy. He never answered me, Brooks. He actually just looked at me and refused to answer me as if I was an idiot. And is that not a pertinent question to ask, though, Brooks?
Oh, it absolutely is. And, we're not the only ones sending a probe up there right now. The Chinese are sending a probe up there right now. An interesting question I was asked. I was in 8th grade, mm-hmm. and I was tutoring fourth graders to help the teachers out there in mathematics, and I was interviewed by the local newspaper, and they asked me, what do you want to do when you grow up? And I didn't hesitate. I said, I want to be an asteroid miner.
Wow.
And that's exactly what China is doing. They're sending a probe to the asteroid belt to look for a mineral-rich asteroid, and they're going to hook onto it, and they're going to tow it back to close to Earth, and they're going to mine it.
Can you imagine getting an asteroid like rich with gold or iridium or something really rare? I mean, it would be the motherlode of all motherlodes, Brooks.
You would say. Now, the Chinese also have a program going where they're going to harvest the helium-3 that's on the surface of the moon. It's estimated to be about 1 meter deep over the entire surface of the moon.
Wow.
And, one shipping container full of helium-3 could power the United States for about 3 years.
Wow. That's crazy. Wow. The Chinese are ones to worry about. They all say about the Russians these days, and, the Russians aren't a problem. I'll leave the Russians alone. I reckon the Chinese are the ones to watch. These guys are incredibly ambitious, Brooks.
I think they're ambitious, yes, but, the Russians don't have 1.2 billion people to feed. Yeah. The Russians are, 1/8 our population. So I don't really think that the mindset of the Russians and the Chinese are the same. Mm-hmm. Chinese have been seriously at war once in the last 60 years, and they lost. Yeah. The Russians are a lot more aggressive, mm-hmm. and the Russians have a bigger problem on their hands. Their currency has collapsed. Their main product, which is oil, it's over half their gross domestic product, has collapsed due to aggressive, I would say, price war by the Saudi Arabians. And it's not really aimed at the Russians. It's aimed at us. They're trying to shut off our shale oil production, which they have done. And they have vowed to keep oil, below $60 a barrel, for the foreseeable future. Although we know that's not true because even they couldn't survive if it stays at that price. Russia has plenty of resources, so they're going to weather it out. And they're probably going to consolidate their banks and their currency, and they will recover. Their currency collapsed back in 1999, I think, and they recovered. So I'm sure that they're going to recover this time. But they do have a different mindset. The Russians are much more prideful, mm-hmm. and much more aggressive than the Chinese, I think. Sure.
Do you think that we're maybe not a space race, but do you think there's like a new space race, probably at a snail's pace, not like the 60s, but the Indians are looking at stuff, the Chinese, the Russians, the Americans. There's a lot more players on the field now, Brooks.
Well, I would say I don't think the Americans are much into it other than space exploration. I think a couple things have to happen to turn our planetary eyes towards space again in a real aggressive way. Number one, we have got to get behind this idea that we have to be at war on this planet. And we've just got to learn how to live with one another. Mm-hmm. And the other is we probably need to have a focus on the energy crisis that we're in. I think we were given a loan by who created this planet, by all the hydrocarbons that were placed into the crust. We've gone through all the easy hydrocarbons.
Oh yeah.
If it were not so, we would not be drilling for shale oil and tar sands. This is very expensive, very messy to extract from the ground.
It's desperation almost, Brooks.
Yeah, it is. I mean, we wouldn't have touched shale oil back in the 80s. No way. Oil just wasn't expensive enough. But when oil gets up around $80 to $100 a barrel, then the $65 a barrel it takes to extract shale oil begins to make economic sense. Mm. It doesn't make sense when oil's $50 a barrel, which is where it's at now. And I can just tell you, I think all the easy oil, all the, spindle tops and the free flowing geysers that could be found in the United States, they've been found. That means that everywhere else on the earth, the original, I'm going to say reservoirs that they tapped into, those are gone. They're having to explore for new oil in new places. Mm-hmm. That's why everybody's fighting over the Arctic, because they say there's the mother lode up there. Well, that may be so, but the ocean's 4,400 meters deep up there. That's a very, very dangerous place to be drilling.
Very hospitable. Wow.
Sure.
Brooks, okay, let's talk about the moon again. How does our moon form? I mean, is our moon not just a major anomaly, even in planetary science? Is this thing just the most weirdest thing ever? I mean, the size and diameter is just at the right distance to give us an eclipse. It's locked into us and it never moves. It's incredibly big compared to our Earth, as opposed to other moon systems. Do we know how this moon is formed? Is it still guesswork?
Well, with some people it's guesswork, with others it's not. I would say it's not so much guesswork for me and for the studies that I've done and others have done like me, because the moon is made of titanium and aluminum, and Earth is made of iron and nickel. Mm-hmm. The moon being the theory that maybe the moon is a piece that broke off of the Earth is utterly ridiculous. Mm-hmm. Now, there were two theories out there. One is called moon capture theory, and the other one's called Earth capture theory. Earth capture theory is that the Earth was in orbit around the sun, and the moon came floating through, and the Earth captured it in its orbit, and that's where it's been ever since. That has been thoroughly discredited. The other theory is called Earth capture theory. That is to say, the moon was in orbit around the Earth with a missing planet. Earth came and joined up with the moon. That theory is still alive and well, and it fits with the story in the Bible. It makes a lot of sense.
Wow. Do you believe we went to the moon, Brooks? There's all sorts of conspiracy theories that we went to the moon, that we didn't go to the moon, that there's aliens on the moon, and then it's like, did we go or did we not go? Did we get warned off? Did we not get warned off? It's like the conspiracy keeps jumping and changing and evolving, but do you believe we actually made it to the moon in the late 60s?
Well, I have to, because the Chinese did a high-resolution camera recording every in strips all the way around the moon, mm-hmm. from an altitude of about, I believe it was 20,000 miles all the way down to the surface. Now, there's no atmosphere to distort the camera. So this is a crystal clear picture of the entire surface of the moon. And they have images of the area where we explored the moon. We didn't land on a whole bunch of different places around the moon. We basically went to the same area every time and explored that area. All that equipment is still there. Wow.
Why don't we go back to the moon, Brooks? Why? I mean, it makes sense if you want to rule the Earth, and if you want to be big nations with big guns, and you want to kill everybody, which is where the state of the planet is in perpetual war. And why not go back to the moon and station your gun? I mean, the moon is locked into the Earth. Why don't you just put your big gun there? And then wait for the countries to pass around as the Earth revolves, and then say, hey, I'm pointing the gun at you, I own the moon. Because whoever owns the moon then owns the Earth, no?
Well, your latter statement is correct. I've always said that whoever controls the moon will control the Earth. To be, 230,000 miles away or 215,000 miles away and shoot something at the Earth, it's not easy. Remember, we tried to hit the moon 4 times with a probe, sure. And we missed it by 30,000 miles. Wow. It doesn't seem like it would be that hard of a thing to do, but we missed it 4 times. The 4th time, or the 5th time we actually hit it, was because the gyroscope inside the craft seized up. It failed. And that's when Wernher von Braun figured out why we were missing the moon. We were changing not the velocity of the craft, but we were changing the curvature of space-time by spinning the gyroscope inside that craft. That heavy weight spinning at 30,000 RPM was actually curving space-time. That's why we were missing the moon. Now, since then, of course, we learned to compensate for it. But it isn't that easy of a thing to do, body from another body. The main thing that it would give us is a base from which we could do heavy lifting. Mm-hmm. At 1/6 our gravity, mm-hmm. It would be a fraction the cost. We could lift 1 million pound space stations into orbit around the Earth, or around the moon for that matter, at a fraction the cost that we mm-hmm. could do it here. Why we haven't gone back? I mean, I grew up at that time. Sure. I remember sitting in front of my TV and watching, the first steps on the moon. I was mesmerized by it. That's why I did my co-op at Jet Propulsion Labs in Pasadena. I was fascinated with it. Mm-hmm. One of my best high school buddies stayed with it, went to work for Hughes Satellite for 18 years. He put up GPS satellites. He put up TV satellites, and now he's a consultant for Anderson Corporation, which is a big consult firm, helps government corporations do business with the U.S. government. I mean, it's a fascinating field. Why in the world we never went back to the moon, I have no idea. Why we had 2 launch engines fully built, crews fully trained, and all the money, everything was paid for. We left those launch engines sitting on the pad and in garages. We never went back. I just don't understand it.
Me neither. And the thing is, even nowadays, Brooks, and look at the mindset of the public, the nations on the planet. I mean, asteroids coming in with an impact to wipe us out. Imagine having a way station like the moon sitting there. Imagine having biodomes built up there and a community. All very, very, yes, it would be difficult to have a supply chain there, but if you had, we have the Eden Project in Cornwall in England, in the UK, with these big giant biodomes, 7 or 8 of them now, with plants and all sorts of climates. You have maritime climates and all sorts of different climate zones inside the homes, and we know we can do it on the Earth here and seal them. Why not build biodomes up there and then live out an impact? I mean,
well, I think it'd be a lot easier than that. We recently, because of these high resolution pictures that were taken of the moon, we've discovered old, what appears to be volcanic vents that go down into the crust. Mm-hmm. And these are quite large, several hundred yards across. We could cap one of those vents and use that shaft to build a city. Inside the crust of the moon. We'd be protected from all the micrometeorites that pepper the surface of the moon all the time. We'd be protected from solar radiation. We'd have plenty of water, plenty of oxygen, and helium-3 to run all of the energy systems that we need. There's so much oxygen and water chemically locked into the soil of the moon that it would be very easy to set up a living system up there. And I think you could exist for much longer at 1/6 gravity than you being weightless in orbit.
I think it's pointless talking about going to Mars. This is just me and my perspective, Brooks. I'm a very practical guy. I'm just thinking, okay, let's say you do get to Mars and back. And yes, you do it when the best launch time is when Mars and Earth and everything lines up. And you get there. What are you going to do? You're going to go and do what you did on the moon? You're going to go park your vehicle, dig up some soil, bring it home. Yeah, great one step for mankind. Yeah, great you walk on Mars. Fine, I understand all that. But, if you want to colonize space, I just think you got to do it on the moon. You got to put a base there and live there. And then, you can say you're on 2 planets then. You say you're living. To live somewhere and visit somewhere is 2 different things, Brooks.
I couldn't agree more. I think that we move from what Carl Sagan called a class 0 society, where we have not even mastered energy supply of our own planet. We move to a class 1 society. We're able to utilize the energy of our own solar system. I think you're exactly right. We move into a different age, but we have to do it as a planet, not as a nation.
Yeah. Can you imagine you knew in advance that you're going to have to evacuate this planet because a massive asteroid was coming in, and you had 10 years on it? Maybe you had 5 years. Maybe we got that sophisticated and we knew that this planet, maybe an asteroid comes around, Brooks, and misses us, but we know when it's next come around in 20 years. Imagine you had 20 years to do that and knowledge that you're going to get hit. You could have this way station on the moon, and yes, it is fear-mongering, and yes, there is a fear factor involved, but even in a positive sense, the mindset to colonize space, because that's what you're doing. If you can't colonize the moon, you're not going to colonize anywhere. That's what I say. So
I tend to agree with you. And if it would have to be one heck of a big, it'd have to be like a planetoid if it's going to really perturb life on Earth. The odds of Earth, little teeny tiny blue speck in space, getting hit by a significant asteroid with Jupiter in the same solar system,
yeah.
The bigger that asteroid is, the easier it is to suck out of the sky by Jupiter.
Sure.
Most, I would say all successful solar systems that have life in them have a planet the size with the gravitational pull of Jupiter, able to take care of those things. But something smaller than that, something that could really cause us trouble, like something the size of a football stadium or something like that.
Sure.
That would be definitely at least continent ending, if not really perturbing to life on Earth. How much easier would it be to shoot out of the sky from a moon that had no atmosphere and a low gravity where it would easily launch a missile at it? How much easier would it be to do from the moon than it would be from Earth?
Yeah, it just makes so much more sense to go back to the moon. I mean, there's so many things you can do there. I think you're right, though, Brooks. You got to sort out the problems on the planet first. You got to get everybody thinking together. And if you look at the Russian space station, Mir, I mean, okay, it's a good start. There's a bit of networking there. Why not do that on the moon?
The International Space Station is a landmark in humanity, to be sure. Now, the recent space station that was launched, the Heaven's Palace, that Chinese launched, they did it as a single nation. And they're continuing to build on it. They're continuing to grow it. They have their own agenda. They have their own thing that they're doing. To come together as a planet is going to take a different mindset. I don't know if we need a common enemy, like maybe an enemy from another world, or whether we need a pandemic, or we need something that's really going to threaten the existence of life here on Earth to motivate us to pull together as a planet, or whether, the world leaders are finally going to come to their senses and say, the whole idea of 80 humans on the Earth owning half the money on the planet makes no sense to any civilization.
Yeah, I said this to somebody the other day, Brooks, on the same hymn sheet. It was an Oxfam poster at a charity shop, and they were trying to incite people for a poll, and they were saying 87 people on the planet own half the wealth, and it's like, it just doesn't add up, does it? It is true, but it doesn't compute the brain in a human sense.
No, you're right. And there's no easy solution. I mean, you can't go to the 87 people and say, okay, all right, you've had it for a few generations. It's time to give it up now. Let's just spread the wealth around. That doesn't work either. The whole idea that we have created a wealth system is what's flawed. The idea that we have a system of exchange between us as humans in the form of money. I do some work here in North Carolina, and I turn it into money, and then I can go to Amazon and buy something from a company in Oregon or Arizona, and they'll ship it to me. And they'll take my contract to pay as exchange for it, and then they'll turn it into something they want in that area. Well, that makes perfect sense from a commerce point of view. But when you look at the whole idea of profiteering, the whole idea of acquiring other companies until everybody's playing poker and the richest guys are all in all the time. Yeah. Then all the small players can't afford to play, so they go away. I heard the CEO of Gallup a couple of weeks ago say it more profoundly from an economic point of view than anything I've heard. He said, we are at a 35-year low in business startups in the United States. Wow. I was yelling at the radio saying, I know why that is. It's not because the entrepreneurial spirit has disappeared from our planet. Hardly. There are plenty of people with good ideas and the fire in the belly to make them happen. The problem is that those people no longer have access to capital. All that capital has been extracted by global banks into one location controlled by a handful of people.
Wow. Of course, Brooks, you are the author of the Arc of Millions of Years series. Tell us where people can get a copy of your books, your website, and of course you also do the scientific radio show, X Squared Radio. So tell people all those links before we go to break, Brooks.
Okay. You can buy the Arc of Millions of Years series easy by going to Amazon or Barnes & Noble or any of the online booksellers. We used to sell in bookstores, but the cost of book insurance got so high that we just sell them online now, and they sell a lot more books online anyway.
Sure.
It is a 1,100-page series on the origin and destiny of the Earth. It has tons of archaeology, hundreds and hundreds of photographs and graphs. Most of the pictures we took ourselves around the world, and a combination of archaeology and physics in an interesting way to explain how the Earth was formed, how we developed on it as a race, and where we seem to be going. The last two books, one is called Remembering the Future, the Physics of the Soul and Time Travel, and that is more or less a self-help book. It's designed to show you how to unlock the bounty of the universe for yourself. It is full of simple mathematics and as an explanation of how to resonate with your own energy, with the energy of the universe, and make it open the cash drawer for you. The last one is called Alienated Nation, The New Path to Liberty. It was written in 2012, and it was designed to awaken the United States of America to the idea of an Article 5 convention run by the states to amend the Constitution and undo the power that the agency government now has over our country.
Wow. Powerful stuff. And, of course, X Squared Radio, that's x2-radio.com. You know what's so good, Brooks, is to have somebody like yourself in the alternative radio network. And to just, because a lot of people are looking to alternative radio for answers now. So it's great to have you on doing the show.
I think it's the only place the answers exist. If you just watch the mainstream media, you're getting the talking points from 6 or 8 origins of information. It's all propaganda.
Yeah.
If you want the real news, you want to know what's really going on in the world, go to the net and listen to some of the alternative news programs, mine and others. We're the ones that are really answering the questions, really connecting the dots for you. And if you want your mind opened, listen to Capricorn Radio, listen to X Squared Radio, listen to Truth Frequency Radio, and you're going to have your mind opened.
For sure. Brooks, we're going to take a quick break. We'll come back. We'll talk about Egypt, spirituality, ancient technology, and mysteries and more. Hi everybody, welcome back to Capricorn Radio. You're talking to your host James, and we got Dr. Brooks Agnew on the line, and what a fascinating discussion so far, Brooks. Welcome back to the show.
Thank you so much.
I know we've got a mutual friend, Robert Boval. I know you spoke to Robert about Egypt before and stuff, and Robert's a veteran of the show. We've been covering a few things going on in Egypt, crisis and stuff. But fellow engineer as well, Robert. What do you think of ancient Egypt? What's your analysis of the mystery there, the technology that these guys had, the abilities that these guys had, and the sophisticated science and know-how, Brooks? I mean, people are going to apply the ancient astronaut theory, and people are going to apply the Atlantis theory, or at least deep antiquity of time. What do you figure out, Brooks, on ancient Egypt?
Well, I've been to Egypt 5 times, and I've visited every major city and some of the smaller towns in Egypt. Mm-hmm. For my opinion, I think the area of Giza is one of the most fascinating areas. And what I see is a vast age disparity between Giza, that is to say, the 3 pyramids that are there, as well as the Sphinx, compared to the rest of Egypt. And in my opinion, it looks like those 3 pyramids and the Sphinx were built perhaps 5,000 years before Egyptus ever walked into the Nile River Valley. Mm-hmm. I think that once they walked into that valley and they saw the splendor of those pyramids coated in limestone casing stones and capped with crystal in utter mathematical perfection, sparkling in the sun, I think they were so blown away that the first thing they tried to do was copy it. And they tried during all the thousands of years that the Egyptians were there to copy them, and they never got close.
Mm-hmm. Wow. Do you ever look at the Bent Pyramid? Did you get out that far?
I have seen that pyramid, and I've seen Saqqara. I've been out to Abu Sir and Abu Ghurab, which is probably 3 kilometers outside the city in the desert. It's not really on the tour, but
Sure.
if you know a good taxi cab and you're willing to spend a few £100, you can get out there.
Sure.
These are pyramids that are just blown to pieces. They're just like something got inside of them and just exploded those granite stones hundreds of yards out into the sand. I've been there. I've dug in the sand with my own hands for days. I've photographed things I've never seen anywhere else on the planet, trying to figure out not only how they were built, but what the heck they were used for has been one of the great challenges of my scientific life. I don't necessarily have all the answers, but I know what they weren't.
Tombs.
They weren't tombs.
Yeah. I don't buy the tombs theory as well. And even if later people came in, like you say, and then tried to copy them and then make them into tombs, I'm okay with that. But there's the original 16 pyramids, if you want to call them that, these old ones, the old kingdom, they definitely seem to be 2 layers of history there, Brooks. I definitely agree with that.
Well, that's true. I mean, you can go to Dendera. That's one of the temples that's got the best rendition of the Hathors there. The other one is Hatshepsut, which is a female pharaoh. She wasn't discovered till late in her reign, but she passed herself off as a man for a long time and got away with it. There's the 2 places where you see the Hathors depicted. If you go to Dendera, you will see half of the complex is quite old. And if you're lucky enough, and I mean it takes some finagling, you can get them to open the crypt underneath Dendera. Now, it's not easy to get to, and you got to be a little bit athletic to get through these small passageways down under the ground. But if you can get there, and you need to take a wide-angle lens with you because the walls are so close together, you can't take a photograph of them because you can only get maybe 4 feet away from them. You'll see the technology of, could have been bioluminescence, it could have been bioelectronics, but you could definitely see where they were using electricity to make light.
Sure.
And when you go into some of these caverns, you realize that this is all pristine, clean limestone. I mean, it's as clean as a piece of paper.
Yeah.
And there is not one single flake of soot on those walls. However long those artists stayed in there, carving those hieroglyphs, and there are millions of them, or carving the reliefs that are on the wall. They illuminated that work with something other than something burning. And when you see the way that they laid the cables from batteries through liquid into what appears to be some kind of filaments or some kind of a solution that gave off light, you could see how they illuminated these caverns with technology that we don't even know how they did it, but we see on the wall how they did it. You'll see also at Dendera the old part and the new part. The old part fits together like a glove. Perfectly smooth stone, hundreds of steps, stone ceilings, great archways. The new part is a bunch of mud bricks compared to the old part. They tried to copy it. They tried to copy it and expand it, and they failed. The differences in archaeology are stunning, and it's the old stuff that's beautiful.
Yeah. You know, I have been to Egypt 3 times, and on one of my excursions to the Valley of the Kings, I remember going down into one of the tombs in the Valley of the Kings and going down this long tunnel, which then took left and then descended again. And, you know, the paint on the ceiling is blue and showing stars and it's fresh and everything's clean down there. And if they used, let's say they didn't use lamps or they used a mirror or something, even if you had the shiniest mirror today, setting aside the technical aspect of shining light round corners and such long distances, it would lose its luminosity by the time it got to where it had to go anyway. But, I mean, it's not even possible.
You'd have to have somebody standing outside with the mirror moving it because the sun is, passing across the sky.
And shining it to the other mirror on the corner to get it inside the next bend as well,
Right.
But it just doesn't make sense, and I understand exactly that problem. That was a long tunnel I went down to one of the tombs. I mean, it doesn't make sense how these guys had something You know, when you see it under the Dendera lamps, though, these like, it looks like giant light bulbs. It couldn't be anything else. I don't even know what else it could be to give it a counter argument. I couldn't even come up with something to say what it is. I mean, I couldn't say it is anything else.
Well, it's clear that they spent a lot of time carving that into the wall. It only exists there. Nowhere else in Egypt do you see it but there. But you can see the cables going from batteries. You can see the red and the blue paint still on the walls. It seems to kind of indicate some kind of polarity. When you put the whole piece together, then you can see it. These pictures only exist a couple of places. I mean, people like me and you that were able to get in there and take photographs, we have the photographic proof ourselves.
Yeah.
Even the photographs on the web, they're rare. Not many people get down in this hole in the ground. If you've been down there, it's small. It's only about 18 inches by 18 inches. You've got to squeeze in there and climb down that ladder to get in there. It's tough.
You know, Brooks, I got into the Serapeum the last time I was there in February. I don't know if you've ever got there. They closed it for 20-something years. So, but I got down there into these Serapeum boxes, and I could see my reflection in black and pink granite boxes. I could actually see that's how these things, and Chris Dunn was there with a titanium straight edge or whatever it is to 1,000th of an inch accuracy, and shining an LED light through it. You can't even see you can't see the light getting through it. That's how it's mirror finished like a telescope mirror. Unbelievable.
That really is incredible. You know, the black granite comes from Sudan. It's 1,000 miles away. This is one of the discussions I have with Rob. When we look at the Great Pyramid, it's a combination of red granite from Aswan, which is 300 miles upstream to the south, and then the black granite, which were much larger blocks. Some of these are 30 tons, and they come from 1,000 miles to the south. And you have to remember, there was no standard system of measurement. There were no wheels. There were no pulleys. There's no river going to Sudan, to Egypt. And I was telling Robert, you know, I have a hard time, even with a standard measurement system and AutoCAD prints, getting exactly what I want delivered to the job site.
Yeah.
In those days where you're trying to get a 30-ton block machine finished so that when 3 blocks are put together, you can't fit a piece of paper between them, that technology did not exist on Earth in those days.
And like you say, Brooks, even just getting it from the location to the location, never mind putting it in place, just getting it from the A to B and having it sitting there ready to go would be a feat in itself.
It's true. I mean, the main structure of the pyramid are these 2 to 3 ton red granite blocks. There are about 1.5 million of them. And then there's another 1 million blocks that are structural blocks that are inside the pyramid. Some of them are standing on their end. Some of them have been removed. They're limestone casing blocks on the outside of the pyramid. I guess when the Egyptians got to that, that would make a nice coffee table at the house. Let's take that off. The only way to move that stuff is to move it by water, upstream to the south, upstream or downstream to the area, and then offload it. Well, the problem is that there was no dam in those days. You had to rely on the Nile River, which was very unpredictable, and it was only navigable, a few months out of the year. The rest of the time it was flooded. And you look along the path, that 300 miles, there's not a single block on that river floor. Not one. They didn't drop a block if they hauled it by water. The other thing is, how do you move that many barges upstream? Well, you have to use oxen to pull the boats with cables upstream, and then you got to move the boats back downstream another 300 yards or 300 miles to get to the source.
It's insane.
This is an incredible undertaking, and in the amount of time that they had to build that pyramid, there just is no way. There's not enough lumber to even build something like that.
So, Brooks, I got a big one for you. Bear with me on this one. Let's think pole shift and also the dating of the pyramids. Because of the pyramid is so incredibly aligned to true north, they say it's 3 times more accurate than Greenwich Mean Time in its alignment to true north. Okay, there may be a dating issue of the Great Pyramid and Sphinx or Giza complex. And And then there's also people talking about a pole shift. Now, I'm not mistaken with this. If there was a pole shift, then that would also affect if the Great Pyramid. The Great Pyramid would have to be aligned to true north after the pole shift. Otherwise, it would be out of alignment. And if it's so accurately aligned, it tells you that the Great Pyramid is aligned after a pole shift. Do we have any evidence of a definite pole shift in the recent past, i.e. Ice Age, stuff like that? And would that be true, that the Great Pyramid being so accurately aligned is aligned after a pole shift?
This is a real common area of confusion. The pyramid is not only aligned to the North Pole of the Earth, it's also aligned within just a couple of arc seconds, which is quite incredible when you think about the antiquity of it, with the star Sirius. And it's not necessarily the star Sirius that you can see, because that's Sirius A. There's a star behind it, which is not nearly as bright. It's kind of blanked out by the brightness of Sirius A, and that is Sirius B, which is a much more gravitational body. It was aligned with that 11,000 years ago, according to where the shafts are in the side of the pyramid. It's still aligned with that star. The reason this is so important is it tells us that the star Sirius and our sun are binary stars, because the Earth has passed through several phases of the precessions of the equinox. Even though our North Star has changed, the alignment with that star has not. Now, to answer the question about the pole shift, they have definitely happened, but not in a geographic sense. It's in a magnetic sense.
Right.
And how we tell this is igneous rock, which is formed when molten rock comes to the surface and then freezes in its solid form. When it freezes, it assumes the magnetic alignment of the planet at that time. And when we go to the Nordic regions, we can see where a lot of this rock is exposed, and in its current position, we can see a vignette of gravitation, or that is to say, magnetic alignments of this ancient igneous rock. So it tells us that the poles of Earth did shift. That is to say, the North Pole was south and the South Pole was north. And right now we are seeing not a drift. A drift would be a few yards a year. The pole is moving across town every year. It's moving so fast now that we're having to sandblast off the compass numbers at the end of runways and change them in order to keep the compasses of the airplanes lined up with the runways. That's how fast it's moving. And this change is not linear. It doesn't just move at this rate until it flips over. It is actually like pushing a top over. When the Coriolis effect takes effect, that is to say, this force that pushes at a right angle to the rotational body, when it gets to a certain point, it very rapidly flips over. Now, the sun does this every 11 years, but the Earth appears to have done this about every 600,000 years or so. And we're about 100,000 years overdue for a pole shift.
Wow.
What will it take to push it over the edge? I don't know. Maybe a very quiet sun like we're seeing right now. We're seeing anomalies in our magnetosphere, in the alignment of the poles. They're wobbling all over the place. We have satellites that watch this now. And it could be 7 months. It could be a week. It could be 7 years to see this pole shift. But it doesn't necessarily mean continents are going to slide around on the face of the planet. It's just a magnetic shift. Is it going to be cataclysmic? It's hard to tell. We know that the atmospheric river is very polar. It does respond to magnetic fields. It could be a reason maybe why we've been messing with weather for the better part of 20 years now with harps around the planet. It could be that we have now disturbed the magnetic field around the planet, and this is why the western side of our continent is now in a severe drought. And it could be why we're seeing in both hemispheres really hot summers and really cold winters. It doesn't make sense. It's not the planet's warming. It's that the extremes between hot and cold are getting wider and wider.
So, okay, I know Charles Hapgood was a proponent for a geographic pole shift, but the physics of that to actually happen, Brooks, would be incredibly difficult, no?
It would be, as there's no real reason why a planet would do this on its own. If a close pass of another gravitational body or a massive gravitational wave from the center of the galaxy, maybe that could precipitate it. But Hapgood's theories of what North America and Europe would look like after a pole shift are well known. His maps are everywhere. We made copies of them, got permission to use his maps in our books, but it doesn't. There's no really historic basis for it happening. There is a historic base for this magnetic shift.
Wow. So the magnetic shift, would that affect, that would obviously affect the biological rhythms of plants and us humans and everything else. I mean, if the north went to south and the south went to north, how big effect would that have on the human race, or on maybe on probably birds and stuff, because they fly to the north, no? So that would probably mess up the whole biological rhythms of probably other species more than humans.
Yeah, I would say that animals that rely on magnetic fields for procreation, for navigation, for germination would definitely be affected. Plants are more solar tropic. They kind of follow the sun, but bacteria, everything from butterflies to schools of fish in the ocean, all rely upon this group think influence of magnetic fields. Human beings, we know from space travelers that when we're away from the magnetosphere, the magnetic and low frequency vibrations of our planet, we tend to have severe biological problems. In all of the space stations and spacecraft, we mimic those vibrations, those low frequency vibrations in those craft. That's how the only way humans can survive for long periods of time away from the planet.
You mentioned HARP there, and there's two types of weather modification. Is that correct? There's what's called cloud seeding, and then there's like HARP, which actually affects the pushing up of the clouds with electromagnetic energy. Is that correct?
Well, I think there might be 3 or 4. Cloud seeding in the old days, where you just kind of drop ice crystals into the high altitude clouds, and it starts the condensation process. It's kind of a chain reaction, and it makes it rain. We're seem to be doing much worse than that. We're seeding the atmosphere with particles, metal particles like aluminum and barium, that hang in the sky for hours and hours and hours to do 2 things. One is to reflect the sun's radiation back out into space, or to collect that warmth in the high altitude and change the weather that way. And the other way is we actually go out into the ocean and we take seawater and we spray it thousands of feet up into the air. The idea is that some of this water will actually evaporate, the salt and everything will fall down to the earth, and the water vapor will continue on up into the sky, and you can actually build clouds at sea. And that's been done actively for several years. And the next one is using HARP, which is an ionospheric heater. You blast this high amplitude frequency out into space, pushing the ionosphere out into space like a huge soap bubble. And when you do that, you create a void in the upper atmosphere, and you can move the jet stream around, which reroutes the atmospheric river. Well, once you do that, you change the way water flows in the upper atmosphere. And that's how you can redirect weather. Now, I'm not saying that you could create a hurricane, but the skill to be able to steer a hurricane once it's formed, to steer that high energy one way or the other, there is the capability of doing that. I've built several cloud chambers on national television for not only History Channel, but also Conspiracy Theories with Jesse Ventura.
Oh, yeah.
And I have shown how frequency can be used to manipulate the water molecules inside these cloud chambers. I've taken a cloud chamber so thick with fog generated from nebulizing water, cold vapor inside this chamber. I can turn the frequency on, and within 10 seconds, all of that water's gone. It's all changed state.
If the weather modification was used for good purposes, as in nobody's behind the closed doors saying, create me a hurricane for that army over there and wipe them out. Let's say there's good intentions for it. Is it a safe technology, Brooks? Let's say there's good intention for using it. Is it safe? I mean, is the Earth going to suffer from this technology? Any of the four methods.
How I became involved in this when Holes in Heaven was being produced, I had written a paper on my ground probing radar that I had developed in the early 80s for exploration of oil and gas. And of particular interest to this group was we were searching for a gas well, a pocket of gas up in Roseburg, Oregon. And it was a foggy morning. I set up my receiving gear in the camper, and then my mobile gear was on an ATV, which drove a couple thousand feet away. And I radioed to him to go ahead and turn the transmitter on. He turned the transmitter on, and less than 3 or 4 seconds, this earthquake goes rumbling underneath us. And of course, he calls me and says, "Wow, did you feel that?" I said, "Yeah, I felt that. What was that?" And he said, I don't know. You told me to turn the transmitter on. I turned it on, and it sounded like, deep in the earth underneath my feet, a bunch of dynamite went off, and it just rumbled in all directions. And he said, "Did we cause that?" I said, "Man, I don't know. I don't think so. We're only working with 50 watts." But I wrote it in my lab notebook, and here I was 15 years later almost, writing it up and publishing it. And Nick Begich and Gene Manning read it. And they contacted me. And so I said, "Well, tell me a little bit about HAARP and what it does." And they said, "Well, it's a array of 2-meter antennas, and they're blasting this frequency out into space, or out into the ionosphere, and they're heating up the ionosphere." And I said, "Well, what frequency are they using?" And so he told me, and I said, it happened to be very close to the base frequency that I was using for my ground probing radar. And I said, that's really dangerous. What kind of power are they using? And they said, "Well, close to 1 billion watts. And
wow.
Man, my skin just began to crawl. And I said, no, you can't use that frequency. You'll create a solar tap. And they said, "Well, what is that?" I said, "Look, I need to talk to you guys." So they got Dr. Bernard Eastland, who's the guy who developed the patents for the Navy in the first place, from which they built HAARP. And we got on the phone, and I said, "Look, Dr. Eastland, we have a problem here. If they're beaming this frequency up into the ionosphere, they can create a solar tap. This is an ionospheric breakdown." Now, we all know what a thundercloud is, because we see the clouds come in, and you see the sort of Van de Graaff movement of air, blowing up to 50,000 feet. It creates a huge static charge. That excess of electrons needs a place to go, and the ground will send up an ion path that reaches up to the cloud, and the lightning will discharge down that ion path to ground. I mean, it'll pulse 40, 50 times in just a couple of seconds until all the electrons are spent and it doesn't have enough voltage to make the jump anymore, and then it stops. And when it stops, the air that's been turned into almost pure energy at 8 million degrees comes slamming back together, and that's the thunder that we hear. I said, that's just a couple of miles up. And that kind of thunderclap or a thunderbolt may be, a foot across. But when you're talking about an ionospheric bolt, you're talking about something jumping 30 to 40 kilometers, not a couple miles. And you're not talking about something a foot across. You're talking about something maybe 2,000 feet across.
Wow.
And when it strikes the ground, just as the cloud, when it spins all of its electrons for that electrons for that bolt, it stops until it builds up another charge. But if the ionosphere discharges into the earth, that will be catastrophic. You're talking 30 to 40 pulses a second for several minutes. And every single pulse would vaporize 6 to 10 inches of solid rock into pure energy. It would be catastrophic to the planet. They have no idea what the risks are. So that's why we published the video on Holes in Heaven, because of the risk of playing with that technology.
What an incredible documentary too, Brooks. Really successful too, HAARP documentary.
Well, it was, Wendy Robbins was a fantastic director, and the producer that we had was totally dedicated to it, and I think they were gifted at what they put together. And technology wasn't that great for making a film like that, in 1997, but it was so widely distributed. It went everywhere. When we did it again for History Channel, in 2006, and then we did it for Conspiracy Theory in 2007. The ability to show what we were talking about on TV was much more well developed, and I think the message got out there. And actually, the HARP that was operating on the North Slope of Alaska is now down to operating very few days a year. But it's not the only one. There are ones in Australia and China and Russia. There's one in South America, and if they work in concert with one another, I mean, you could re-terraform the Earth.
Wow, it's incredible. This is powerful. Powerful technology that I don't think people really understand, as you say, Brooks, that they don't really get what they're doing. Like, they really don't.
Well, you asked the question, could it be used as, to benefit the planet? I honestly don't think the scientific group that's working with this technology knows how to benefit the planet with this.
Yeah.
But I do know where the money came from. The money to build it came from the Defense Department.
Yeah.
So it's not being used to help the planet. It could be actually used as a weapon system.
Yeah. Yeah, and a very powerful and effective weapon system. A covert one as well. Oh, well, that was just a hurricane. That was just bad weather that day. Oops. Incredibly fascinating. Brooks, what's new for you? What are you working on these days? What are you doing?
Well, I'm almost totally focused on getting this electric truck onto the market. We've been working pretty heavily since 2008 on it, but in the last couple of years, we received better funding. We made a couple of breakthroughs in our drive technology. This last year, we applied a bunch of lightweighting technology and some lightweighting structural steel technology in our body. We got the weight of the truck down to easy 1,000 pounds lighter than any other pickup truck on the market. We're 1,500 pounds lighter than a full-size truck, and yet we can carry the same payload. We are the only all-electric pickup truck on the market, and we've just now completed our federal crash testing. So we're waiting for that certification from the DOT, which should come sometime this year, maybe later on this year, and then it's ready to hit the market in the United States.
Oh, wonderful. Well, I wish you every success with that. I got one last curveball question for you, Brooks. Are you a spiritual guy, and do you believe in reincarnation?
I am a spiritual guy in the sense that I'm no longer religious. I was for a long time. I grew past that. I am a spiritual person, and that I look for the good in other people. I believe that the energy that we put out with our consciousness and our intention maybe goes beyond the concept of karma. It actually contributes to the overall resonance of a planet, maybe a solar system, maybe the universe. Reincarnation, that's a really good question. I think that the spirit that makes up a human is eternal. I think that right now we're having a mortal experience, and I sincerely believe with all of my heart it's not the only mortal experience we have had, whether on this world or other worlds. You can doubt that if you want to, but I reckon time will tell.
For sure. Wow, Brooks, incredibly interesting talking to you. What an intellectual guy. I've got to get back sometime soon and not leave it as long again. But Brooks, I really, really thank you for your time today. Such a fascinating guy.
It's my pleasure, James. Anytime. Capricorn Radio rocks.
Wow.
Engineer. And when I worked in the field for about 10 years, I was going to go back and get an advanced degree. And I went to my supervisor and I said, I want to go back and get an MBA. He said, don't waste time. I mean, an MBA, I have an MBA. It hasn't helped me at all. He said, if you want to do something, go get a degree in statistics, like quality. I said, what? So I started the master's course, and the first year I was bored out of my brain because of all the math. But then I started to see how the mathematics helped me analyze manufacturing. Then I started to see, how to improve processes, how to fight root cause analysis, how to do variation prevention, and the whole world of manufacturing opened up to me.
Mm-hmm.
Well, just because I knew what was wrong with the world, I wanted to know what were the solutions. How do I design things to make it better?
Mm-hmm.
And that's where the physics came in. And I already had a physics thesis done from my undergraduate work when I was in the oil business as in the exploration side.
Mm-hmm.
And I had a ton of field data. So my proctor just encouraged me to write it up and take the classes to back it up. I did that. It was terrifically hard because most of the classes I took were extension courses, which means you're not sitting in a classroom. You're slugging your way through the textbook on your own and then talking to a professor a couple times a week. And frankly, about 75% of the students drop out because they just don't have the determination to go through it. They'd rather sit in a classroom for 3 or 4 years and get the degree that way. But there are a few.
Hi, everybody, and welcome back to Capricorn Radio. This is your host, James, and I'm delighted to have a returning guest today. We're going to be talking to Dr. Brooks Agnew, previous guest on the show. Had such a fascinating discussion last time. Really looking forward to getting a few updates with Dr. Brooks Agnew today. A little bit about Brooks before I bring him on. Raised in Pasadena, California, Dr. Brooks Agnew spent most of his youth hanging around Caltech and the folks who co-opt at the Jet Propulsion Labs. Entered the Air Force in '73, where he became an electronics engineer. And after earning an honorable discharge, he attended Brigham Young, Western Kentucky, and Tennessee Technology Universities. He has a bachelor's degree in chemistry, a master's degree in statistics, and a PhD in physics. He was featured scientist in the '97 Wendy Robbins documentary on HARP, Holes in Heaven, and if you haven't checked that out, you got to get a copy. He's currently the president and CEO of Vision Motor Cars Incorporated, designing and manufacturing affordable electric vehicles for highway use. Without further ado, let's bring on our super exciting guest. Hi, Brooks. Welcome to the show.
Oh, it is good to be back on Capricorn Radio. Thanks.
Brooks, great to have you back. You know, the funny thing is, I think we talked about this last time, Brooks, but I was in Stranraer yesterday. I came home through your native town on the boat yesterday back to Belfast.
Really?
Yeah, because I don't normally get the boat. I went over for a TV interview in Glasgow, and I've been navigating around Scotland, and it's been such a long time since I went back to Scotland. I used to live in Lockerbie in South Scotland, but I was thinking about it because I was like, how strange I have Brooks Agnew on the show tomorrow, and I'm coming through his hometown of Stranraer.
So. I know, that's great. Yeah, Stranraer, no one really associates it with us, but you're local.
Say that, but it's mind-bending to get there sometimes.
Yeah, it really is.
Wow. So, Brooks, I mean, we talked about Hollow Earth last time. We're going to probably get into that again. What is it about the public consciousness that is just absorbing this stuff, Brooks? I mean, people are philosophizing about this. They want to know, not just a fanciful idea of Hollow Earth. They want to get into some of the physics. And I find the public consciousness, it's absorbing more physical concepts these days. They're more into science. They're more into history. The layman's knowledge is really high these days, Brooks. But the public consciousness is just absorbing this whole hollow earth theory, like it's the last day on Earth.
Mm-hmm. And it's probably one of the more remarkable things about this style of planetary core geology that just blows my mind. I got involved in the project in 2005 when I was trying to find out some more information about at least how ancient civilizations viewed the advent of that maybe the earth might be hollow. There were all kinds of legends. I found them in Egypt. I found them in Scotland. I found them in Tibet, China. And there were traditions, even in the Christian records, even in the Bible, it talked about, the lost 10 tribes coming forth out of a highway of ice out of the center of the earth. And so I found it fascinating, but I also found it impossible because, I was, learned like everybody else that we live, everyone knows, on a molten bulking Agnew Bay right next to Agnew Park.
Yeah, and then it's such a beautiful part of the world. I love South Scotland. Most people don't get to visit it unless you're going to either Northern Ireland on the ferry or we look across towards the southwest Scotland. You see across from Antrim, but beautiful part of the world. And it's such a long time since I did that route, Brooks. I was thinking of you yesterday in your hometown. But yeah, such rich history around there. The castles around there are gorgeous, and it's just beautiful territory. Absolutely beautiful.
Yeah, it really is. I've been there once. I stayed a few days there, and it was really good to meet all the people and, to see the heritage of Agnew everywhere, all the cemeteries and the castles and the legends and the artwork.
And the fine really Scotch whiskey as well, Brooks.
That's right.
For sure. Brooks, the last time we had you on the show, we were talking about a multitude of things. I guess I'll probably go back to hollow earth for a bit and talk about some of the physics of that as well. And, you are the serious physicist. I want to point that out before we get into anything what we're going to talk about. Yes, we're going to talk some alternative stuff, but you are a serious physicist. You've got multitudes of papers out there. But tell us a little bit about that part of your life. You're also into electronic engineering, so you're a hands-on physicist. You seem to be in both worlds, and I find, and just this is for the listeners more than anything, Brooks, I find you either find two types of people in this world in the science. You got the physicists or you got the engineers, and there never seems to be a migration from one to the other.
I know that's a sad thing. The physicists are always hiring engineers, and vice versa. So. I started out as a few that make their way all the way through, and I got the degree, and man, it was satisfying in the sense that now I really had the skill set to be able to, write a thesis like that. But it was also a detriment in that it made me practically unemployable.
Mm-hmm. Yeah, I come from an engineering background myself, Brooks, and mechanical engineering, and I did a physics astronomy degree. I couldn't do any more than that. To be honest with you, it was just too much for me. The statistics that is in quantum physics, it's just crazy. I mean, the math I struggled a bit with, and I'm good at math, but I mean, it's heavy math. I mean, so I commend you on the statistics and the math.
Well, people get, excuse me. People get lost in probability theory, and it's easy to do permutations and combinations, but the integrations and differential equations, that's where, it separates the men from the boys, I guess. I found that it helped me, get to solutions a lot quicker. And I was really kind of frustrated that my calculus teacher didn't show me that years before, because it would have made a lot of things a lot easier. But you really have to have that mindset. I think I often say it takes a really twisted mind to be good at this. And
I agree.
Most of the theoretical physicists that I know are not terrifically good mathematicians, and vice versa.
Yeah. You know what? I remember it was partial differentiation I had. I just thought it was mind-bending. But when I got it to work and I seen it, it was beautiful.
It is beautiful.
It's beauty. If there is beauty in mathematics, I will put my hand on heart